Assalamu alaikum. Myself Sahil Aziz, and I'm gonna talk about wind energy. What is wind energy? As we all know, wind energy or wind power is the use of wind to provide mechanical power through wind turbines to turn electric generators for electrical power. And this electrical power can be used for home, farm, school, or business applications in small residential area, medium communities, and large utility scales. Moreover, in recent years, wind energy has become one of the most economical renewable energy technology. Today, electricity generating wind turbines employ proven and tested technology and provide a secure and sustainable energy supply. First of all, I'm gonna talk about wind turbines. Basically, wind turbines are the rotating machines that can be used to generate electricity from the kinetic power of the wind. This wind rotates the turbine blades. These turbine blades spins a shaft connected to a generator. The spinning of the shaft in the generator makes electricity. In simple words, working of the turbine is just opposite of the fan. That is, in fan, wind is produced by electricity, but in turbine, electricity is generated by wind. Wind turbines span a wide range of sizes, from small rooftop turbines generating less than 100 kilowatts up to large commercial wind turbines in the megawatt power range, many of which operate in large clusters called wind farms. They are broadly grouped in two categories based on the orientation of the axis of rotation. First one, horizontal axis wind turbines or HOTS. Second one, vertical axis wind turbines or WATS. In HOTS, rotating axis of the wind turbine is horizontal or parallel to the ground, whereas in WATS, rotating axis of the wind turbine is vertical or perpendicular to the ground. HOTS are primarily used in big wind applications, whereas watts are used in small wind projects and residential applications. One advantage of watt over the hot is that it doesn't require yaw mechanism, since it can harness wind from any direction. How much power is in the wind? The power in the wind is proportional to the area of windmill being swept by the wind and the cube of the wind speed and the air density. The formula used for calculating the power in the wind is the power is equal to density of air into swept area into velocity cubed, where P is power in watts, rho is the air density in kilograms per cubic meter, A is the swept rotor area in square meters, and V is the wind speed in meter per second. Here, figure 1 shows the power captured by a wind turbine, and figure 2 shows the graph of the wind speed, power, and height, in which the wind speed at 10 meter height is 15 meter per second. At 20 meter height, the wind speed is 17.2 meter per second, and there is 0.94 megawatt of power available in the wind for a 300 meter square capture area. At 60 meters, the wind speed is about 25% higher, but the power is almost doubled at 1.8 megawatt. Not all of this power can be captured by a wind turbine due to physical limits. It can be shown theoretically that any windmill can only possibly extract a maximum of 59.3% of the power from the wind. That is known as the Betts limit. In reality, this figure is usually around 45% for a large electricity producing turbine. Lift and drag forces. Lift and drag forces are the two types of aerodynamic forces which are created whenever the winds or anything moves through the air or air flows over any surface. So basically the lift and drag are the components of force. Drag forces are in the direction of the airflow, whereas the lift forces are the perpendicular to the airflow. Here in the figure, the resultant force or force vector is resolved trigonometrically into these components of lift and drag, and the angle of attack is the angle between the chord of an airfoil and the direction of the relative wind. Okay, this is the inner structure of the turbine, which consists of several components. Here the turbine rotor, generator and gearbox are the main three components for energy conversion. Rotor capture wind's energy and convert it to rotational energy of shaft. Shaft transfers rotational energy into generator. Nacelle casing that holds and the gearbox increases the speed of shaft between rotor hub and generator. Now, the generator uses rotational energy of shaft to generate electricity using electromagnetism. Yaw controller moves rotor to align with direction of wind. Brakes stop rotation of shaft in case of power overload or system failure. Tower supports rotor and nacelle and lifts entire setup to higher elevation where blades can safely clear the ground. Up till now, we have seen the working of the entire components. So, the working principle of the wind energy system is the energy in the wind turns two or three blades around a rotor. The rotor is connected to the main shaft, which spins a generator to create electricity. Wind turbines convert the kinetic energy in the wind into mechanical power. Here are some wind energy control schemes which can be used to either optimize or limit power output. There are two control methods. One is pitch adjustment and the other is yaw adjustment. Pitch angle adjustment is the most effective way to limit output power by changing aerodynamic force on the blade at high wind speed. Whereas the yaw adjustment or yaw control ensures that the turbine is constantly facing into the wind to maximize the effective rotor area and as a result power. In next slide, both the controlling methods and several control strategies are shown. Here, figure 1 shows the pitch adjustment, figure 2 shows the yaw adjustment, and the graph below shows the four controlling strategies, that is fixed speed, fixed pitch, fixed speed, variable speed, fixed pitch, and variable speed, variable pitch. Advantages of wind energy. As we all know, wind energy is environmental friendly because its generation produces no pollution or greenhouse gases. Thus, there is also no consumption of fossil fuels, and wind energy is absolutely free. Small footprints because it occupies less space, and the maintenance is also too low, and it's also sustainable. It creates jobs, and there are several many advantages of the wind energy system. Here are some disadvantages. The wind fluctuations. Wind fluctuations impact on the power system stability as well as the very small fluctuations in wind speed causes cyclic loading on turbine blades and can lead to damage. Wind turbine creates lots of noise pollution, and the installation is also too expensive. Furthermore, spinning turbine blades can pose a threat to flying wildlife like birds and bats. And that brings me to the end of my presentation. Let me give you a summary of what I've been talking about over the last few minutes. Wind energy is probably the solution for our energy demands. It has great potential and is easy to manage. All you have to do is build the turbine and everything else is going to be free. With only one turbine, you can power over 200 homes. Every wind turbine lasts for about 20 to 25 years. As long as the wind blows, wind turbines can harness the wind to create power. Many people believe that the wind energy could soon be our main source of energy. Wind energy is rapidly increasing with the passage of time. Government as well as world is putting efforts to understand its importance and bringing best out of it. Thank you.